The final section of the worksheet of the mixer is the PF spec. The PF here is standard for a pressure flow specification. So this is important to understand. Here in Aspen HYSYS, we can simulate a steady state and a dynamic. Okay, what is the difference? The steady state, this is a simple simulation. You need to choose a specific time and choose this condition to simulate your equipment. Like we decided on maybe the 23rd of March, we are going at maybe 10 a.m. to take all the data from our plant, like the data from the plant, like the temperature, the pressure, the flow of all the equipment and the material stream, and all this data will be added to the simulation in Aspen HYSYS. So this is one data point at a specific time. So the time here is constant, but the real simulation, the time is changing, right? Changing of time. So this is the difference. Here we are like running a real-time plant. The time is changing, and so the temperature, the flow, and the pressure. The temperature here will not be our concern in the dynamic, only the pressure and the flow. So what happened in the steady state? If you remember, while simulating our steady state of the material stream natural gas, we define the temperature, the pressure, and the flow. Because this is a steady state, we took this information from the plant and we decide that. But this is not the real case. Why? Because in actual simulation or in actual plant, there is a relation between the pressure and the flow. Or to be more accurate, if we are talking about the dynamic or real time, there is a relation between the pressure and the flow. This relation between the pressure and the flow means that if you have a pressure difference, it will affect the flow, which means if I have this separator or a mixer like this, in our example we're talking about a mixer, so let me draw here a mixer. Okay, I am having a mixer over here. I have two inlets and one outlet. Okay, so here I have a pressure 1, pressure 2, and the third pressure. Okay, the flow in the third one. So if I increase the pressure over here, like I multiply it by 2, this will affect the pressure is increasing here, means it is pushing the flow in this direction. This will for sure affect the flow over here. So by increasing the pressure or changing the delta B is the pressure difference or the pressure drop over the unit operation, this will affect the flow. This is dynamic. But if we are talking about the pressure that is not changing and the flow that is not changing, and I am fixing them and they are user defined, so this one I am a user, I have already defined them, that's why they are user defined. This one should be calculated and changing by Aspen HYSYS by adding a controller. So we are going to see this through the course, but this is really important at this point to understand that if we are talking about the dynamic, we are talking about the relation between the pressure and the flow. So if we have an equipment, okay, if we look over here and we have an equipment like the separator, when we come to the separator, we will find out we have an inlet and maybe 2 outlets, the vapor and the liquid over here, the vapor and the liquid, and here we have our feed. Okay, in a steady state, you are going to define here the information that you are going to define will be the temperature, the pressure, and the flow. Here it will be the temperature, the pressure, flow. We have here temperature, pressure, flow. Okay, but while doing the dynamic simulation, you will define the pressure and the flow will be calculated, or you are going to define the flow and the pressure will be calculated. Okay, so this is the difference between the steady state. This is one of the differences between the steady state and the dynamic state. So back over here, the worksheet, the PF spec, this is mainly for the dynamic, which means here we are here if we look, you have pressure spec active, and this is the value of pressure. This is a flow spec active, which means we also have defined the flow, and it's active and it is defined to be, this is the value. Okay, this is the value that I've defined. Okay, because we are dealing with a steady state, we can define both the pressure spec and the flow spec. But for the dynamic, as I told you before, we can't define both of them. You need to choose if it's a pressure specified or a flow specified, and the second parameter will be calculated based on the information that we have already added. Okay, so after that we have a dynamic here. If we are talking about the dynamic, before we have talked that the pressure specification should be equalize all. The dynamic can't run for set to the lowest inlet, it's an equalize all. Okay, we have here the hold up, this or is the information. The hold up, this is accumulation. This section we have talked about before. We have an inlet, and the total of the inlet should be equal to the total of the outlet. But sometimes we have a hold up or the accumulation amount inside the mixer or any other unit operation that will be deducted from the outlet value. Okay, the strip short, this one will be really important for the dynamic simulation, because having a strip short is the best way to visualize or to track the change in the BID. Okay, so I just want to make it simple right now. So here we have our solvent, how we know that our one is converged. This streams will be in blue, dark blue. Our mixer will be in gray and black. Okay, if it's in yellow, we need to define some information. If this one is in light blue, means we need to define more or add more information. Okay, so now we have our mixer in a steady state. So in our next video, we are going to transfer this mixer into the dynamic state.